Designing in 3D with SolidWorks delivers unmatched productivity gains. Errors are reduced, parts fit together the first time, and physical prototypes can be eliminated. In today's competitive landscape, keeping costs down without sacrificing quality is paramount. But how can we minimize costly materials used in a design and still ensure that it functions correctly? In this transfer mechanism, we need to remove material from the bracket castings and the torsion tube. But how do we find the locations in which to remove material, and how light can we actually make it? Can we understand the forces experienced by each component without building a prototype? SolidWorks Motion allows users to simulate the conveyor operation and obtain the loads in the linkage system all within the familiar CAD environment. These loads can then be used in SolidWorks simulation to evaluate the strength of the design. This really takes the guesswork out of determining the input needs for the calculations. While we can study the entire structure, let's just focus on the pivot linkage. The results show areas of high stress in red and low stress in blue. But how do you know if the stress is too high? The factor of safety plot compares stress in the model to the material yield. A number greater than 1 means that it will not yield. Here we see the part is over-engineered for its application, so we can reduce material and save on manufacturing costs. Now that we understand the working loads, optimization couldn't be easier. Being part of the SolidWorks environment makes geometry changes child's play. All the designer has to do is pick what features he would like to change and a dimensional range over which they can vary. In this case, we let SolidWorks vary the web, flange, and hole offset thickness, as well as the torsional tube's wall thickness. We also set a constraint that stress must remain below 50 megapascals. SolidWorks Simulation does the rest of the hard work, trying many different geometry combinations to find which one requires the least amount of material, while still keeping stress within an acceptable range. In a matter of minutes, a new, more efficient design is achieved with very little effort. In this design, we were able to reduce the weight from 10.5 kilograms to 6.15 kilograms. That's a 40% weight saving. We can also see that the maximum stress is still below our goal of 50 megapascals, and while we've removed a lot of material, the factor of safety is still quite acceptable. What used to take hours or days can now be